Good morning, everybody.
Good morning.
Good morning.
How are you guys doing?
Good. How are you?
Good. Doing good. Doing good. Rushing around, and I was like, oh, I have class. It's hard to work from home, you know? You start like laundry and kids, and it's very hard to separate the two things, but it's good. Everything's good. Did you all see the Z-score practice, this right here, this homework thing that I put up? Maybe not. I didn't clarify, which I should put that on there, that we will go ahead and have it count as a homework, and I'll have it open. It's definitely good practice, okay? And I'm going to use it to kind of go through the talk today and the presentation. And so it's kind of like a review, okay? It'll be like a review for the test that's coming up. So I don't know if y'all saw the video from yesterday, but I just want to let you all know that I know that this is kind of craziness, right? I know probably not any one of you signed up to have statistics online. Our original thoughts were all to have it face-to-face. And so I couldn't imagine trying to take this class online. And so just know that I 100% feel for you guys. I understand what you're going through. On the same part, it's new for me too. I've never taught statistics online. So I'm trying, to not add stress to you guys. So let's just go with that, okay? No stress. We're going to get through this, and we'll figure out along the way what's the best way to do things. This exam that's coming up, I know exams are scary, and I know exams have their own level of stress that's added to them. So I might, what I was telling the class yesterday, that I might open it up like Thursday and just have it open for quite some time, not have the time, constraint on it, so that you all could just take it and it's more like an assignment rather than an exam. Okay, so that there's not a time crunch and that you can really work through it and so on. Okay, I'm more interested in you all just learning the information, and that you can go on and move on from here and do whatever it is that you need to do and take forward with you the knowledge from this class. Okay, so know that I will 100% focus on the things that you have to know for whatever those next classes are. Okay, so I put up this assignment, and it's purposeful. There's a mix of questions and problems, and it will help you really start to understand the Z-scores, the normal distribution, and then getting into percentiles, okay? So I'm not gonna work through it because that doesn't do anything for you all, okay? Because I know when I do it, 100% of the time it works out, right? We come up with the answer. I want you all to do it so that you can find where it is that you get stuck. What happens? What part don't you understand? Where is it that it doesn't make sense and you need help on? And your process of going through that is so much more beneficial than just sitting there watching me do it, okay? So I'm going to use this. I'm going to split screen this, and we'll use this, and I'll go over and work examples as we go through it, okay? Has anyone already completed it? No? Okay. All right. And that's not a trick question or anything. I just wanted to know. So just in case, right? Just in case that if you guys had any questions or anything like that. So this first part, let's just zoom through it real quick and then we'll go over it. So this first part is just calculating the z-score, okay? So we'll work through that if we don't remember how to calculate z-scores. These right here, these multiple choice questions, and I'm sorry about that formatting right there. That stuff drives me nuts. It wasn't like that when I made it, and then I don't know. But anyway, so these are just multiple choice questions that are really kind of getting you all to start thinking about the z-score, the normal distribution, and what all that means. So this is kind of your, like, just your mind having you really start to understand it. And as you read through them, or as I'm talking for this hour, you know, read through them. If you have a question, ask and we can discuss it, and that helps everybody, okay? This one is finding those proportions in the Z table. Okay, we did a little bit of that last week. And then here's an actual problem that you would work out on your own. You would find z-scores, and then you would find percentile rankings. Okay, all right, so this is a really good snapshot of what the exam would expect from you. Okay. So I'm going to split screen that, and let's pull up our PowerPoint slides here. Okay. Get on this one. Okay. Let's find a spot. Okay. I don't want that to happen. Okay, there we go. All right. So these first questions 1 through 5 is finding the z-scores. Okay. And if you remember, let's see, I'm going to make this a little bit bigger. I'm definitely showing my age. I've started realizing that it's hard for me to see little writing sometimes now. And I'm like, oh, all right. So there's the formula for a z-score. Okay. And again, remember, we're not going to really get too worried about the population mean, whether it's population or sample, and then the population standard deviation, whether it's population or sample. We don't, at this point, we don't need to care about that, okay? We just need to know it's always the raw score minus the mean divided by the standard deviation, okay? So these are examples over here. These are all our IQ examples, because IQ is such a nice and easy number, 100 being the average, and then 15 being the standard deviation. So let's do an example real quick. I'm going to get up red. Hopefully it'll stand out a little bit better. Okay, so let's do an example. Does somebody want to pick an IQ? Pick an IQ score that you might have in the top of your head or something? Anyone? No? Which one?
115.
Oh, 115? Oh, that's okay. That's a good one. So 115. All right. So what we do is, to find the z-score, you put that raw score first. So that person's z-score, that person's IQ would go first, and then minus 100. Oops, that's supposed to be 100, divided by 15, okay? So 115 minus 100 would leave us with 15. Let me scoot this over a little bit. Divided by 15, we would get a z-score of 1, okay? And remember, z-scores are scores that are represented in terms of standard deviation. How is this person deviating from the mean? Okay, so this 100% completely makes sense, right? I'm going to try and draw this down here. Ooh, that was bad. That if we drew out IQ, we have 100 right in the center, right? And it tells us that standard deviation is 15, right? That we know the next IQ would be 115 and then 130 and so on, okay? And you draw a line right there. Well, that also corresponds with one standard deviation above the mean, okay? One standard deviation above the mean because 15 is the standard deviation, okay? Any questions on that? Pretty straightforward, huh? Let's see. Oh, I won't erase it yet because someone might be writing it down. Let's pick another.
Excuse me, I have a question. So which one of in the formula is the raw score?
The raw score is right here, the X.
Okay.
Okay. Yeah, this is raw score. Let's see, I'll just put RS. This is going to be the mean, or like in this example, you can see it says the average score of an IQ test is 100. That's going to be your mean, okay, your average. And then down here is standard deviation, okay?
Okay, thank you.
Yes, good question, good question. Okay, so let's go with a IQ that's below 100. Let's see. I just thought in my head, let's do 78. Okay. I don't know who this is, but we'll call him Johnny or something. So Johnny has an IQ of 78. Okay. So let's figure out what his Z-score is. Sorry, I just have to turn it a little bit so I can write. Z is equal to, we put 78 first because that's his raw score, minus 100, which is the mean, divided by 15, the standard deviation. I don't trust myself on math like that. 78 minus 100, so I get negative 22. Divided by 15. Divided by 15 gives me negative 1.46666666 on and on and on. Okay, so what I'm going to do, I'll just round up that 6, and I'm going to say that his Z is equal to negative 1.47. Okay. Are we all okay with that? Are we see where those numbers came from?
But is it going to stay negative, or we have to put it on positive?
Okay, yeah, and I had this question yesterday, and it's probably my fault because I confused everybody. It will stay negative because he is below the mean, right? He's under 100. So it'll stay negative. But Irene, what I think you're alluding to is when we look up that value in the table, remember I was talking about that, and I was saying we don't necessarily have to worry about whether it's positive or negative. So that is true. Like if we had to look up his, that value in the table, we're not going to find a negative 147. We just find 1.47. Okay. But we still need to keep his Z-score a negative because he is below an IQ of 100. It's a Z-score that's on the other side. Okay, good question. And thank you for that, because we do need to or I need to clarify that. Okay. So his z-score of negative 1.47 would probably fall, I don't know, maybe somewhere around here. Okay. Let's see, let me move this a little bit. So his IQ was 78, right? Is that what I picked? I don't remember now. Was 78, and his z-score was negative 1.4. That's too hard for me to write down there, right? And this guy was at a z-score of 1. That you don't have to do that. I'm just drawing that so that you can kind of visualize where they are on that distribution. Okay, you don't have to draw the distribution or that on any of these right here, the 1 through 5. Okay, just the number is good enough.
I have a question.
Yes.
Is the standard deviation for IQ always 15?
That's exactly right. Yeah. Yeah, IQ, and this is why, you know, I've been talking about it for what, all these different times. It's just, it's the average is 100 and the standard deviation is 15, and it has just been that way forever. And so that's why it just makes it such a nice example to work with. Yeah. Other things are not like that, you know, like height, you know, for it depends on what gender you are, it depends on how old you are. And then it's things like, I don't know, you know, 53 inches, and then the standard deviation is like 2.4. You know, so they're just kind of hard, not hard numbers to work with, but these are just so nice and clean and whole. So yeah, but good question. You know, I think it's kind of interesting. Like, you would think people maybe would get smarter over the years, right? Like maybe IQ would change and you would have some fluctuation in standard deviation and stuff, but not over all the years that I've known. So good question. I like that question. Like, yeah, anyways, I could go off, but it makes me wonder, like, we have those, you know, we always learn in history and stuff, all these amazing people like Einstein and, you know, I don't know, Galileo or Newton or whoever. Like, do we have people like that now? You know, are there things left to still discover, or are we just so bombarded with information that we don't have one person that just seems to like rise above and be so amazing in their intelligence? I don't know. It's kind of an interesting thing to talk about. There's a big debate too about like what is intelligence, and you know, is this test even valid for really capturing someone's intelligence? So if you go further, Cassandra, are you a psychology major?
No.
Oh, you're not? You know, what are you studying?
I'm studying, well, ultimately I want to do a speech language pathology.
Oh, yeah. Yeah.
Yes.
Yeah. Oh, that's fascinating. Yeah. Always, and sorry, not to just assume you would be psychology. Oh, speech, that's so fun. That's a good area to go into. They make some big bank, so that's good. Yeah, but you'd still probably study some stuff with intelligence and all of those good things. So yeah, there's lots of different intelligence tests out there too.
Like, if I'm going for forensic psychology, sorry, Miss Valles,
that's okay.
I need a lot more, right? I would need that class you're talking about.
The general experimental, or which one, or intelligence?
Or the one you then like I would need to take intelligence courses?
Oh, something with intelligence. You know, I don't know if I mean, it depends on which school you go to. If you're planning on going to UTEP, I don't know. The only one
I don't think they have the forensic psychology at UTEP.
Yeah, they have like psychology and law. You know, they're really actually kind of nationally known for that. But yeah, as far as forensic psychology, I'm not sure how how much you could get into that. But intelligence, the only one I can think of at UTEP that would start to touch on intelligence would be definitely like a cognitive psychology class. And then I can 100% think of this class in your in graduate school, but it was more, it was learning about all of the assessments. So we learned all about the test, the neuropsych testing and intelligence assessment. So we learned how to administer those those tests. And we learned, you know, all about that, but it wasn't like necessarily like a debate about intelligence, if that makes sense. Yeah, that's a good, have you looked into that, Cynthia? Because I don't know.
I have, and most of the schools are not here. One was the University of Chicago for psychology,
Yeah.
which they have a couple campuses. There's one in Chicago, there's one in DC, there's one in, I want to say it's New Jersey. It's not actually New York. But yeah, my options for here in El Paso, no, but it's okay because my husband's military anyway, so it's not like we're gonna stay here.
Oh yeah. Okay, that's cool. We've been watching Criminal Minds Criminal Minds, like we pop on, like if we don't know what to watch and we can't like sit there and like binge something, or we don't want to cheat on somebody with a show, we watch Criminal Minds, and man, we just love that whole, you know, FBI behavioral analysis and stuff. It's so cool. So that's really neat. And when you go on and you do that, you remember me over here at Rio Grande campus and come talk to me, okay?
I will definitely come back.
Okay. All right, so let's move on just a little bit. I'm gonna look at these. I don't want to necessarily answer them for you, because I do want you to think about them when you're doing it. But someone yesterday had asked about this one right here. A Z-score of 2.5 indicates a raw score that is close to the mean, much smaller than the mean, much larger than the mean, or 2.5 times larger than the mean. We can immediately mark out D, because we're not working, we don't really do that. We're not multiplying anything by the mean or anything like that. So we don't do that one, okay? Does anyone have a guess on this one? What a Z-score of 2.5 would be in relation to the mean?
A, close to the mean.
That's a good guess. It unfortunately is not right, but it is a good guess. Let's look on here, right? So we see the mean is right here, okay? And then 2.5 would be way over here, okay? Yeah, do we see that now? So this one, and it's, so it's down to these two, right? And this is stuff, Cassandra, we would not know, right? I mean, who out there just talks about Z-scores and standard deviations? We don't know this stuff. So a Z-score of 2.5 would be over here, okay? And when we convert that into, or we can think about the mean, that's saying that this person is 2.5 standard deviations above the mean, okay? And that's really quite far, all right, from the mean. And we also know that since 2.5 is positive, that it will always, always, always be above the mean, okay? If it's a negative Z-score, it's below the mean. And what that tells us is that the raw score would be smaller than the mean. If it's a positive, the raw score is larger than the mean, okay? And we can think of IQ in this sense, right? If we think of in our head, like we have, okay, the mean is 100. If somebody has an IQ of 130, they're above the mean. Their 130 is larger than 100. And that z-score, we can just think in our head, that z-score is going to be a positive z-score. Okay, if we're at IQ, let's go back to the middle. If we're at IQ of 100 and we have somebody that has an IQ of 77, we know that they're going to be below the mean. We know 77 is smaller than 100, and we know that that z-score is going to be negative. Okay, if we look in here, right, the mean is equal to 0. Okay, the mean will have a raw score, or I'm sorry, the mean will have a z-score of 0 because z-scores are telling us how are we different from the mean. And so if you are equal to the mean, if your IQ is 100, then you don't deviate from the mean. There's no difference there. So let's show that, right? If we had an IQ of 100 and we know that the mean is 100 divided by standard deviation, right? No matter what, it's going to be 0. Our z-score is 0. If the mean is equal to, if our raw score is equal to the mean, the z-score will be 0 because they're not different than the mean. They're not deviating from that. Okay, so any z-score that's really small, like 0.12, you know, negative 0.34, if it's a really small number and it's very close to the mean here, if it's very close, then that means, or a very small z-score number, then that means that it's very close to the mean. Okay, they're going to have like an IQ of 101, 102, 103, okay, or 99, 98, something like that. Okay, and that's when we would have a z-score that's very close to the mean or close to 0. Okay, are we cool with that? I just wanted to, we'll talk more about it, or we'll talk, you know, we'll go over this. And I think some of this other stuff is really going to help also, okay, when we start looking at percentiles. Oh, okay, not yet. Let's play with this one where we look up our values in the table. Okay. So
in the one we were talking about, sorry.
No, that's okay.
The score of 2.5, the right answer would be 2.5 times larger than the mean?
No, it would be
No, either?
no, right. The C, the much larger than the mean.
Just much larger? Okay.
Yes. Yeah. Yeah, because we're not multiplying any numbers by the mean or anything. We're not doing that.
Okay.
Yeah. So it's C.
It's much larger.
It's
Okay.
much larger. Yeah.
Can I ask something about that one too, really quick?
Oh yeah, of course.
Okay, so what you were saying then was that if the, sorry, I wrote it down. If the z-score is positive, it indicates a raw score larger than the mean, and then like vice versa?
Uh-huh.
Okay.
Yeah. So like, look at all of these, right? All of these, oh, I did not mean to do that. All of these are positive numbers, okay? And so we can, since IQ works so nice, right? We can put IQ on here just so we like can have a visualization of what, you know, what it would really look like, okay? Oops, that's supposed to be 85. 70 and then 55. So what I did was I moved in increments of 15. That's where I got those numbers from, okay? Because that's the standard deviation. So if we have positive z-scores, which are all of these over here, right? They're all positive numbers. Then we can look down at those IQs and we see those are all values. Those are all raw scores that are above the mean, okay? All of these negatives on this end, right, all have z-scores that are below the mean, Okay, so they're smaller than the mean, less than, negative. And we know with a distribution like this that a lot of people are right in the center, right? A lot of people are in here. This is the vast majority of people. And it's very extreme. It's very different to have people out in the tails, okay? Like Einstein and people that have really low IQs. The other example, so when we say things like it's very large or it's very far away from the mean, okay?
Can I have another question?
Uh-huh.
But I don't know if she's finished. If her question is finished, I don't want to interrupt.
Yeah.
Okay. When you in the number one, because I don't think that exam is gonna be the same. To say that it's close to the mean, it has to be which number? Close to the mean, it was a range between 1 and -1, or what would be close to the mean?
I think so. I would definitely say that, Irene, I would definitely say that within one standard deviation, within one standard deviation, you are really close to the mean. Yeah. Okay. And I agree with you. And I know, please know, when I'm making the test, I have not done this test yet. And these questions that I got from here, I literally cut and paste from this author's study guide, okay? This is how he writes stuff. I don't really like these questions because I think it's a little confusing. And I can definitely see where people could get hung up. I don't like this question at all. I think it's good for visualization, but that's kind of hard to get to that point in my head, I think. So when I pick the questions for the test, I promise you, I'm going to read through the question and I'm going to read through every answer choice to make sure that there's nothing tricky. There's nothing like a gotcha kind of thing. I'm interested in that you know the information. Okay, I'm not interested in trying to trick anyone or anything like that. So I understand what you're saying, that it's like, okay, the test isn't going to be like that, right? They always ask random questions that we don't know about. I'm going to try my hardest, okay, to not do that to you. Okay, that they should be pretty obvious answers. I don't think these are obvious answers. Okay, I don't think these are obvious at all, and that's why I'm just, yeah, it's just to read through it and so that we can start thinking about this. Okay. But I would definitely say within one standard deviation, you are close to the mean, okay? Because these people here, this is the vast majority of a population, and you're not really deviating from the mean. We would say you're pretty average, okay? Between 85 and 115 IQ, that is really, in fact, it's almost 70% of the population is what this graph is telling me. Okay, does that make sense? Yeah, you like that one? Yeah, I would say within one standard deviation. Okay. All right, good question. Anyone else have any other questions about this? I know we're moving on. So I just made that statement, right? I just made a pretty bold statement that I said about 70% of people are within one standard deviation. And I want to show that to you and explain that to you. Oops, I can't draw straight lines, guys. So if I looked up one standard deviation, or sorry, one z-score, same thing, but if I looked up a z-score of 1 in our table, okay, where are you? 1, where are you? 1, there we are. Okay, 1, a z-score of 1 gives us 3, 4, 1, 3. 3, 4, 1, 3. Whoa. And so what that means, oops, is that little chunk right there, 0.3413, is the proportion of people. And we know since a standard or a normal distribution is symmetrical, what's true on one side is true on the other. Okay, so we have a proportion of 0.3413 above the mean, and we have a proportion of 3413 below the mean. If we added this up, you don't have to do this, I'm just showing you this, okay? If we added this up, it would be 68.26. Oh, sorry, I put my decimal already. I started moving it into, I put it into percentage. So this is showing us that, sorry, that's supposed to be a percentage. It's not working very well. That 68% of people walking on this planet are in between 1 standard deviation of the mean, either above or below. Okay, so the vast majority of people are within 1 standard deviation. Okay, especially with IQ. That's really cool. You know, I know we always tell ourselves you're unique and special, and it's like, well, we're also just pretty average, right? Which is, I guess, a good thing. I don't know if that's comforting or not, but yeah. And then I know there's another one. I always forget this proportion in here. I mean, obviously I could figure it out, but anyways, I can't think of it exactly. It's like 0.12 or something like that. If you looked at all and you added up all of this chunk here, you get to about 95%. So 95% of the population is within 2 standard deviations. And that there also really shows how extreme it is to be on those tails, okay? That 95% of the people are within here. So, all right, sorry, that was a little much, I know. And we don't,